So we got, I think, this far, maybe even a little bit further. See how far we got. Trying to get this to disappear. What happened? My computer just did something new. Got this screen up there twice now. How do I get it back? This is going to let me draw on this, but it's not going to let me go on to the next slide. So what's wrong? I guess close that. There we go. There we go. All right, we're back. All right, this is 3-bromobutanoic acid. Yeah, we went on to this. I said there can be a dioic, propane dioic. Somehow this didn't stop. Here was the slide. Is this the furthest we got yesterday? Or did we get further? It's about as far as we got? Okay. Okay, so that shows you the 6 that you should know these names. So, and you're going to see, we'll start using these names like butyric, and you're going to hear butyrate. You're going to see what happens there. Lactic acid. There is a biodegradable plastic, polylactic acid. You can take this naturally occurring or lactic acid. You can take potato peels from McDonald's French fries. Do you think they have a lot of potato peels? And bacteria can chew on that and turn it into lactic acid. And you can turn that lactic acid into polylactic acid, and it's plastic. The plastic. But the beauty of it is, put it in a landfill, and the bacteria will eat it up and break it back down. It's a plastic that doesn't stick around for a long time. What? Well, they do. Lay's potato chips 4 or 5 years ago started packaging their Sun Chips in polylactic acid plastic bags. But they ran out of, they couldn't get enough, there wasn't enough people making polylactic acid plastic to keep them in production that way. California has some laws that encourage recycling of things and really enhance that kind of industry. So maybe in California, are you from California? In California they may have it actually where they package the stuff in polylactic acid bags. I mean, it sounds kind of, you say, well, it looks just like plastic. You get it, it's a plastic bag. But you put it in a landfill and it doesn't stay there for 1,000 years. And as a matter of fact, Northwest Vista College 6 years ago got a grant from Lay's potato chips to study how fast polylactic acid will decay in a landfill. We got a $15,000 grant from them to just kind of put it in a compost pile and see how long it took to disappear.
What was it?
I don't know. I didn't get the grant. It doesn't mean I wasn't interested. That's a good question. How'd it come out? Can't install updates. I'm sorry, folks. Gotta all do. Okay, so let's move on. Oh, we got further than yeah, we got to this. Okay, reactions. Now hang on to that one. You still got something on the back side of this blank sheet of paper. I said we're going to look at 5 kind of 5 reactions. The first one is very, very simple, but we'll do it. Hydrolysis. Or, I'll tell you what, let's change that a little bit. We'll call it dissociation. Running out of these. I'm not. 2 more. Okay, everybody get one of these? Okay, before we get to that reaction, let's just take, and under hydrolysis, why don't you, let's call this dissociation. And we'll do the real simple one, acetic acid. In water, you put this in water and it dissociates. This is what makes it acidic. And acetic acid will dissociate, and what we would call this, we would refer to this as the acetate ion. When you pull that, when that hydrogen isn't there for whatever reason, we're going to change the name from acetic to acetate. Here's the acetate ion. And this is why the water is got a lower pH, because there's hydrogen ion. In 1305, you learned that pH is the negative the log of the hydrogen ion concentration in the solution, whatever the solution is. And so you raise that hydrogen ion concentration, it lowers the pH. And just to show you the contrast, if we take another molecule that looks similar but isn't a carboxylic acid, it's alcohol. This H is not an acidic hydrogen. It won't dissociate. You put this in water, it dissolves in the water, but it does not dissociate. So what's floating around in the water? Those molecules. Those ethanol molecules are floating around in the water as a complete molecular unit. And so this does not lower the pH because it's not a free hydrogen ion floating around in the water. If you looked at the two solutions, they'd look the same. You'd say, oh, the alcohol has dissolved in the water. There's just one continuous layer of liquid. You'd look at the vinegar. You'd say the vinegar has dissolved in the water. But no, it actually dissociated a little bit. Only about 1% of it dissociates, but that's enough to make the solution acidic. Come on. Okay, so that's dissociation. And any carboxylic acid will do that a little bit. It's a weak acid. Okay, the next reaction I've got there, neutralization. Okay, acetic acid, and these might come up in the slides a little bit later. I'm sorry, I'm not as familiar with. Acetic acid is an acid. So this is an acid, acetic acid. We just saw why it is an acid. And if we reacted it with a base, so acetic acid plus a base, it's going to neutralize. The acid and the base are going to react with each other and form a salt and water. And so what happens, here is that this acid reacts with that base and forms water. There's your water. And this takes the place of that, and you get an ionic compound, a salt. That's what salts are. They're ionic compounds. And this is sodium acetate. All right, we got rid of the hydrogen, so we're going to change the name from acetic to acetate. We're going to drop the IC and add ATE, and that is sodium acetate. Very soluble in water, actually more soluble in water than the acetic acid itself. Sodium acetate. They're both very soluble in water. Now, some of you have already caught on to the fact that I'm using what name is this of this material? What is it? The IUPAC name? It's a common name. This is the common name of that acid. So what's the IUPAC name? Ethanoic. Ethanoic acid. And so in a similar fashion here, if we wanted to come over here and look at the IUPAC name of this, it would be sodium ethanoate. We're going to drop the IC and add ATE. Ethanoate. And this is a neutralization reaction. Just like you learned in 1305, neutralization is when an acid reacts with a base, forms a salt and water. Pardon me? An ether?
Yeah.
No, it's not an ether. O8? No, an ether would be a COC bond. Are you thinking of something where this came up before?
I meant ester.
Yeah, that's not an ester yet, but that's how we're going to name esters. We're going to use this same convention. We're not going to have a sodium here. We're going to have something else here. We're going to have something else on there, but we're going to name half the ester that way. You'll see that in a minute. Okay, I better pick up back to my slide so I don't forget something. We mentioned this already. This comes under the category of how would you make a carboxylic acid? Well, you could start with a primary alcohol and convert that primary alcohol into an aldehyde by oxidation and oxidize it further into a carboxylic acid. Less hydrogen, lost 2 hydrogens, more oxygen, gained another oxygen. All of that is oxidation. Okay, so we're getting now into reactions. And so that would be, how do you prepare carboxylic acid? Yeah, here's the trail. To the right, more further oxidation. Coming back from the right to the left is reduction. All right, we just went over this. Dissociation, what are we calling this? Dissociation. So there's your carboxylic acid. You get the carboxylate anion and a hydrogen ion. This is what makes them weak acids. Here's neutralization. Carboxylic acids do react with strong bases to form carboxylate salts. They'll react with weak bases as well. They just react with bases. And there's your sodium carboxylate. We called the earlier one sodium acetate because we knew what R was. R was a CH3 group. This is a general term, so that this is your carboxylate ion, whatever it is, carboxylate. Acetic acid makes the acetate ion in particular, and water.
So the sodium is not necessarily attached, but
it's attracted because of the opposite charges. That's why this is an ionic compound. A lot of times we're doing this. This is not ionic. This is a covalent bond. This isn't a covalent bond. This is a positive ion being attracted to a negative ion, and it's going to form a crystalline compound. An ionic crystalline compound like salt, like table salt. Okay, this goes over some of what I'm talking about in terms of naming. This OIC, I should change that slide because we're changing the IC to ATE. Just keep that in mind. Just replace the IC with ATE and it'll get you the right name all the time. So ethanoic becomes ethanoate. We don't drop off the OIC. I need to make a change to that slide. Benzoic becomes benzoate. And these things are preservatives. Sodium propanoate, calcium propanoate. They're preservatives. Sodium benzoate, found in cranberries, prunes, ketchup, etc. I don't think they're saying this is found in cranberries. This is found in canned cranberries, where they want to preserve the cranberries. Okay, this isn't a natural ingredient of cranberries. Coca-Cola used to use that as a preservative in their Cokes, and then whether they never, I don't think the studies ever demonstrated conclusively that it could form benzene, but it said under certain conditions this thing could decompose into benzene, which is a carcinogen, and so Coke stopped using this as a preservative in Cokes. All right? Here's zinc undeclinate. Okay, here's a zinc undeclinate. Undeclinate. Why? There's 8, 9, 10, 11. Okay? Instead of decane, we got undecane, or 11. Yes? I'm not good at Spanish. And so what's 11 for Spanish? Once. Okay. That's probably Latin. So we're going from dec, 10, to we're adding 1, undec.
sounds like under.
Yeah.
10.
But it's not under 10, it's over 10. 8, 9, 10, 11. So that's in athlete's foot. That's a antifungal agent. And then these things here, citric acid and sodium citrate, the sodium salt of citric acid, makes a buffer used to control. So this is a buffer. And you learned that in 1305. The salt of a weak acid and the salt of the weak acid mixed together makes a buffer. So that can kind of hold it, like at pH 6. It'll just stay there. Buffers the solution. Okay, let's see here. Okay, you see where I have neutralization of a carboxylic acid? Put this in there. There's a carboxylic acid. It's reacting with a base. In this case, it's potassium hydroxide. So complete that reaction. Write out your structure, this, and complete that reaction. If someone wants to come up here and write it on the board, they could. Done one yet? No?
Would this be the end? This after?
Yeah.
This is gonna be here.
Yep. Wow, over half the class has done this already. Okay. Yeah, you got that? Does everybody have that? Yeah. Okay, now I'll tell you what, as a class, thank you, Alejandro. Let's go ahead and name this. What is this carboxylic acid called? Propanoic. And what is its common name? Propionic. Okay, and this is potassium hydroxide. So what is the name of this salt? Let's go off of this. What's the name of this salt on here? Potassium propanoate. All we drop is this. Propanoate. Potassium propanoate. That's the name of the salt. Okay. let me see if we get to esters here soon. Are we getting to esters? Oh, here's the polylactic acid. Here's lactic acid, polylactic acid. I've already told you about that. So what do you mean by poly? Well, this is your monomer, and now you're linking the lactic acid to more lactic acids in a chain, and you get polylactic acid. Biodegradable polymers from garbage. Okay, esters. I'll describe what an ester is. I'll give you about 4 esters, the names of 4 esters, and you can draw them, and we'll take a break during that period of time. So let's introduce this. This is the second half of chapter 14. Very, very, very important part. We're taking what is an ester? An ester has a carbonyl and an ether linkage. So you really have this situation in an ester. You have the carbonyl and a carbon-oxygen-carbon bond in an ester. You're going to find that in the ester somewhere. In a condensed formula, it might look like this. A COOC. Where what's over here could be almost anything. What's over here could be almost anything else. But you've got that thing in the middle. That's the ester link, or ester functional group. Esters are mildly polar, somewhat water-soluble. They're not as polar as carboxylic acids. Carboxylic acid has a hydrogen on an oxygen. Esters don't have that. They've got the carbon on the oxygen instead of the hydrogen. So they're a little bit okay. If I blindfolded you and walked you into, or a friend of yours blindfolded you and walked you into HEB and walked you into the produce section, you know, you might be able to take you over somewhere and say, "Hey, where are you?" And go, "Pineapples. I smell pineapples." Yeah, you're near the pineapples. Or I smell bananas. Oh, you are. You're near the bananas. I smell strawberries. What are you smelling? You're smelling esters. That's what you're smelling. These are flowers, and all kinds of things are giving off esters, aromatic or volatile ester compounds. So here's pineapple, ethyl butanoate or ethyl butyrate. We'll get into naming these. So isoamyl acetate is banana oil. Ethyl butanoate, pineapple aroma. Isobutyl formate is the aroma coming off of raspberries. All right, so all these different fruits have a different ester. Now, don't get hung up on, oh, can I name these? But just start getting a little familiar with the names. Isobutyl methanoate, 3-methylbutyl-ethanoate, octyl ethanoate. Here's your ethanoate. There's your octyl group. Methylbutanoate. Methyl right here. Here's your butanoate group. I don't know if that's big enough for you to see all that. Okay, here's where we actually got this is a thiol ester. We've replaced that oxygen right there with a sulfur. But that's strawberries. That's coming off of strawberries. So that's kind of a unusual ester there. Apricots. Why do these fruits smell differently? They're producing different biochemical compounds in there, and different esters in particular. Okay. All right. Okay. I said we would draw some esters. Yeah, let's look at how to name some of these esters. So let me dissect an example for you and then give you a couple other names. Let's take a real simple one. Methyl acetate. How do we name these esters? Well, I'm sorry. It is going to be a little bit easier for you to understand the naming after you learn how esters are made. So I'm going to back up here a second. Esterification. Okay, so underneath neutralization of carboxylic acids, we're down here to our third reaction here, esterification. And what I want you to put in those blanks right there is this. You got 4 blanks there. Blank plus a blank yields a blank plus a blank. Pretty neat, huh? Here's the 4 blanks. That's the first blank. A carboxylic acid plus an alcohol yields an ester plus, you can put water or H2O, whatever you want to put there. But that is the general esterification, that's the general recipe for making an ester. And so a reaction that makes an ester, we call it esterification. How do you form esters? By esterification. This one here should put the water in there. So this is a dehydration. You're losing water. Where's the water coming from? The OH on the alcohol and the H on the carboxylic acid. There's your H2O. It's where the water comes from. You're condensing these 2 molecules onto themselves and forming a new single organic molecule and drawing out a molecule of water. Okay, let me write that one down here. Here's our propanoic acid. Here is our methanol. I'm going to just turn my methanol molecule around just so you can see. And I'll write the product down below here. Here's our ester. Here's our ester right here. Now, and then we're going to get water. There's our water. How do we name these? Well, we start with naming the alcohol that it came from. So this is going to be called methyl, and we end with the carboxylic acid portion that it came from. We've lost the hydrogen, so we change it from propanoic acid to propanoate. So it's methyl propanoate. That's the name of that ester. Methyl propanoate. All right, so if I gave you this name and said draw that molecule, what you would look at is you would look at this name right here, propanoate. You'd say, okay, that has 3 carbons on it. This is the portion that is going to have the carbonyl and oxygen on it. All right? And the methyl is just going to be methyl. Methyl propanoate. All right, well, we'll wrap your head around a few of these now. Draw these molecules. Ethyl acetate, and draw methyl benzoate. Yeah, go ahead and draw those two. Take a break. Someone write them on the board. Yeah, so we're going to have, you write them right underneath these things. Now let's take about a 7-minute break. these two make it an 18 carbon fatty acid. 16, 17, 18.
So they're both 18?
Yeah, they're both 18. Yeah, they're both 18. The only difference is the oleic has a double bond right in the middle. Yeah, you got it. Well, you're doing the hard one.
If it's not on our way, we'll learn from there.
It really didn't matter where you put that.
It doesn't matter? Okay.
No. No, wait a minute. Wait.
No?
What are you doing? You're doing methyl benzoate. Oh, did I just move it? I just moved it. Methyl benzoate. No, we're not there yet. Okay, so let's start out with benzoic acid. Start out. Joel, do you know what benzoic acid is? Benzoic acid.
I'll just let somebody else do
It's a hard one.
it. I tried.
It's a hard one. You can do it right underneath there. Right underneath the name. See the name? There you go. Okay. Okay, there you go. Okay, now you see, Vanessa, where we have an ester now?
Yeah.
See, you were going to put a methyl on the benzene ring, but that wouldn't have been an ester. See, if you had put a methyl group right here, you wouldn't have had an ester. We had something else. This is an ester. You have to have this right here. So this is your methyl benzoate, and whenever you see something like that, imagine what you're starting with. You're starting with benzoic acid, and you're going to react it with methanol, and that's going to put your methyl group right here. All right, this is a harder one because, well, that's just a little more difficult carboxylic acid, but it's just a carboxylic acid. Don't worry about this. This is the important thing right here. But this has to be attached to that to get that benzoate. This is benzoate. That's benzoate. Benzoate. That's benzoic acid, and that's methyl benzoate. Okay? Methyl benzoate. Okay. Ethyl acetate or ethyl ethanoate. Okay, Matthew got there's 2 carbons on every portion of this molecule. This one is a little easier because the acetate has 2 carbons, the ethyl has 2 carbons. Oh, okay, let me give you... Did I give you chapter 14 homework yet?
Yes.
Okay. Let me take a peek at that.
hard to use. I know. But that's that. And then I use.
Okay, let me help you out. Or not, I'm not going to let the class help you guys out on your homework. Look at problem 2 on chapter 14. So 2B and 2C. Can we fit these in right here? I think so. If we go up real high, I want 2 more people to take a crack at these. We just did methyl benzoate, so let's do ethyl benzoate. And right here, we're going to do phenyl ethanoate. All right, so do those. Take out your homework, work on those in pencil. Let's get them up on the board and compare them. We want to compare them with each other. Oh, okay, there you go.